Have you ever been curious how structural engineers keep buildings standing during earthquakes? Let's discuss one key principle that engineers use to make it happen. Out in the wild, you may see things like X-braces or solid walls that prevent buildings from falling down sideways. However, there is a building type that doesn't rely on braces or walls. These are called moment frame structures. These frames instead rely on their beams, their columns, and their connections to one another in order to resist earthquake forces. Now, here's the interesting part. If a column yields, aka deforms and gets beaten up under load, instead of the beam, the joint within the building can become unstable and can cause a collapse. That's why engineers follow a strict concept called the strong column, weak beam rule. In structural engineering material codes, it's a certain percentage higher in strength that the column needs to be in relation to the beam. This rule must be kept in mind constantly throughout the design of a structure. If a beam happens to change size because of the demand on that beam, the column also needs to be checked against that increased beam size. Most oftentimes, that means the column, along with the beam, needs to increase in size or increase in strength. Think of it, if you will, like breaking a wishbone during the holidays. One side of the wishbone is a beam, the other side a column, and the middle is the joint that connects both of them together. When you and your family member pull apart the two bones, one of them will stay attached to the main joint while the other will break free. When you do this, you never really know which side is going to break over the other. Engineers don't want to leave this up to chance in their building designs. They always want to know how that frame is going to break so that it can remain safe. We design our structures to make sure that the building remains standing, everyone can evacuate safely, the building can be evaluated safely in a post-evaluation, and those frames yield and absorb energy during that seismic event exactly where we want them to.